Okay, in this video we're going to go through this question. We're going to determine the shortest distance from the point H52 to the line through points J, -6,4 and K, -2,4. So like always, the first thing I want to do with these types of problems is draw a picture, because even if I don't know what to do, a picture is going to help me visualize possible approaches. So I'm going to plot these points on here and label them. Again, this doesn't have to be exact, it can be just a rough sketch. So -6, 4, let's say, is around here. So we're going to call this J at -6, 4, and then -2, -4, let's put that about there. So I'm going to call this K at -2, -4. Now, the question says, determine the shortest distance from the point H52, 52, which is right here, H52, to the line through the points J and K. So we have to imagine that there's a line that comes through these 2 points here. So we're just going to sketch in a line here. It doesn't have to be perfect. So now I have this problem, and I want to find the shortest distance from the point H to this line. And as we've discussed, the shortest distance is going to be the line, let's actually erase this, that if we extend a line from H to the other line in question, they should intersect at 90 degrees. So the first thing I want to do is I need to find the equation of both of these lines. And then once I find the equation of both these lines, I can find where they intersect. And then once I find the intersection point, I can then find the distance, D. So to help me visualize this, I'm going to start by giving some labels here. I'm going to call this line L1. I'm going to call this line L2. So let's start by finding L1. So L1, of course, has the form y equals mx plus b. And I need to first find m. So the slope of L1, is equal to, and we're going to say -4 minus 4 over -6. Sorry, not -6, pardon me. Minus 2 minus -6, which is going to give me -8 over +4, which is going to give me -2. So therefore, if we now know that line 1 has y equals -2x plus b, I can sub either of the points from that line, which would be -6, 4, or -2, -4. So let's sub -2, -4 in, and let's find b. So we get -4 is equal to -2 times -2 plus b. And we rearrange this, we get -8 is equal to b. Therefore, line 1 is the equation y equals -2x minus 8. And again, once I get to this point, I can go through and do a couple checks. The slope is negative, which is good. The y-intercept should be a negative, and it makes sense that the y-intercept is below -4. Excellent. So now, let's deal with line 1. So line 1 is going to again have the equation y equals mx plus b. Since line 1 is perpendicular to line 2, we know that the slope of line 1 is equal to the negative reciprocal of this, the slope of line 2 is equal to the negative reciprocal of the slope of line 1, so that's -1 over -2, which is +1/2. And that makes sense in the context to our drawing, because our slope definitely looks positive. So now, therefore, we have y equals 1/2 x plus b. And now what I want to do is I'm going to sub a point on that line, and the only point we have is 5, 2. So I'm going to sub 5, 2 into that equation to solve for b. So 2 is equal to 1/2 times 5 plus b, and I end up with b is equal to -1/2. So therefore, line 2 is the equation y equals 1/2 x minus 1/2. And if I look at this, yes, the slope is positive. Yes, it intercepts below the x-axis, which, again, this is a sketch. So since it's so close, you have to be careful that you don't rely too much on your diagram here. You could end up with a positive slope, and you would want to be sure that your diagram is reasonably accurate here. So now that we have those two lines, we can find this point of intersection. Let's call this point of intersection D. We can find point D. So we're going to scroll down a little bit here. If I know that L2, let's just change colors here. We know that line 1 is y equals negative 2x minus 8, and line L2 is y equals 1/2 x minus 1/2. Since these two lines intersect, I'm interested in when line 1 is equal to line 2. So therefore, I can say negative 2x minus 8 is equal to 1/2 x minus 1/2. And now I can go through and solve for x. So I'm going to apply here clearing fractions. Clearing fractions is the process of multiplying both sides of the equation by the denominator. So I end up with negative 4x minus 16 equals x minus 1. And now I'm going to simplify this, so I get minus 5x is equal to, and then I'm going to get positive 15, so x is equal to negative 3. So therefore, if x is equal to negative 3, y is equal to negative 2 times negative 3 minus 8. And you can see I've just subbed x into equation 1, or line 1. So y is equal to 6 minus 8. And so y is equal to minus 2. And if we scroll up, then we look, that seems to make sense as far as my diagram shows. So now we want to find the distance between h and d. So the distance, so if we know, let's change colors here again. So we're just going to grab a new color. What color is this? That's pink. Okay, let's finish up in pink. So now we know D is the point negative 3, negative 2, and we know H is the point 5, 2. And let me just scroll up quickly to confirm that. 5, 2. We want to find the distance between those. So D is equal to the square root of, and then I'm going to take the x part component, so 5 minus minus 3 all squared, plus the y components, so 2 minus minus 2 all squared. So that's equal to the square root of 5 minus minus 3 is going to give me 8 squared, plus 2 minus minus 2 is going to give me 4 squared. I'm just going to come back up here. So D is equal to the square root of 64 plus 16, which is equal to the square root of 64 plus 16 is going to give me root 80. And at this point I can get my calculator out and I can say root 80 is approximately equal to 8.944. And I'm going to take this to 3 decimal places because there's no context to this question, and 3 decimal places is usually a safe bet. So again, I scroll up just to recap. What I now know is that the distance between the shortest distance from H to this line is 8.944 units. I hope that helped.